Swayam Prabha. Digital India. Educated India.
Hello and welcome back everyone. We are learning the basics of building construction. Now we have arrived towards the end of the course and we are going to start learning about the temporary structures that are needed for the construction process. In the first part, we are going to start talking about shoring and scaffolding and then gradually move towards other temporary structures used in construction. So let's first talk about shoring. What do we mean by this term? Shoring are temporary structures that are constructed to provide some amount of temporary support to unsafe structural elements in a building. So let's say there's a part of a building, a wall, which has become temporarily unsafe and it requires additional support from a lateral direction. We can use shoring to do so. Shoring provides necessary precautions to prevent damage to any person due to the collapse of any structure, and it provides lateral support to walls, as I already mentioned. Now, what are the situations in which one would want to go for shoring? First of all, when the wall starts showing signs of bulging, this may be due to bad workmanship or use of poor materials in the construction of the wall. If the wall undergoes some amount of bulging, we know that it is a little unsafe, it may collapse and cause damage. So we want to go for shoring to protect this unsafe wall. There might also be unequal settlement of foundation causing the wall to crack, that might need some repairing. In those situations also we will go for shoring. When an adjacent structure has to be dismantled, many a times we need to take support. So for that also shoring finds use. And also in situations when we want to make openings or we want to create some form of an enlarged opening in an existing wall, we want to protect the wall from collapsing while we are making this opening. In that case, we can go for a particular type of shoring. So let's start talking about the types of shoring. We will also understand in which situation these different types are suitable for usage. So shoring, we can either use each of these types individually or we can use them in combination with one another. The first type is called raking shores and they are used for supporting a combination of vertical and horizontal loadings. Usually they are inclined and they are supporting a wall by taking support from the ground. Flying shores are an alternative to raking shores, and we use this when we need a clear working space at the ground level. So let's say we cannot take support from the ground and we need to support this wall at a level higher than the ground, we will go for flying shores. Dead shores are primarily used for carrying vertical loadings. So let's say we are creating an opening in a wall and we want to give support to the portion above the opening, we can go for dead shores. So let's dive a little bit more in detail into each of these types. The first is raking shore. So raking shores are used to provide lateral support. So they are made up of inclined members. These members are what are called rakers. As you can see in the figure alongside, there are rakers used. So these are inclined members which are taking support from the ground and are supporting the wall in turn from collapsing. Now raking shore also has different component parts. The first, of course, as we were already talking about it, the rakers are the inclined members. Now generally we incline them at about 45 to 75 degrees. We don't exceed 75 degrees angle when we are supporting the unsafe wall with the help of the ground. We also use wall plates. Now wall plates are, as you can see, attached to the wall, the portion that I'm coloring with red. This is where the rakers are coming and meeting, and they are connected to these wall plates with the help of needles and cleats, as one can see here. These are helping us connect the wall plate and the rakers to this unsafe wall. To provide additional support, we also use bracings. These bracings, as you can see, are members which are at 90 degrees to the rakers for additional support. And we also have something called a sole plate, which is right at the bottom of the raker, where the raking shows are taking support from the ground to support this adjoining wall. So, in case of a raker, the top portion of the raker is shaped as such, as shown in this figure. This is where the needle and the cleat is going to come in, and we are going to attach this wall plate and the raker to the unsafe wall that needs our support. So, how do we construct such temporary structures, raking shores? First of all, the wall plates, which are about 20 to 25 centimeter wide and they are about 5 to 7.5 centimeter in thickness, they are placed vertically along the face of the wall. So, this is where the wall plate will be placed, along the face of the wall. The needles, which are about 10 to 7.5 centimeters, are used to secure the wall plates onto the wall. The cleats are then used to further strengthen the needles, which are nailed directly into the wall plate. Now, the center line of the raker should meet the wall at the floor level. So, if you see the rakers in the figure, you will see that they are meeting at the various floor levels. To prevent buckling, they are interconnected with struts and braces. The feet of the rakers are secured to an inclined sole plate. So, if one sees the figure carefully, the sole plate is slightly inclined. It is not placed exactly horizontally into the ground. Iron hoops are used to further stiffen the feet of the rakers near the sole plate. Now, why are we doing that? We are doing it to prevent the sole plate from slipping. So, whenever we take support from the ground, if we don't hold something here, it will slip. So, that is the main purpose of the sole plate, and along with it the hoop irons, which are being additionally placed to ensure that the sole plate doesn't slip. The rakers where they are meeting at the bottom with the sole plate don't slip from their position, because once that happens, the unsafe wall will not get the lateral support that it was hoping from the raking shores. The pressure is also uniformly distributed throughout the wall with the help of a wall plate. So, we do not want to put additional pressure in only a single point of the wall, because already the wall is bulging or it is unsafe or weak. So, we want to equally distribute this support, this load throughout the entire wall with the help of a wall plate. For more efficiency, rakers should be inclined to the ground at about 45 degrees. In practice, we make the angle vary between 45 to 75. Now, towards the top of the rakers, we have something called the top raker, which is then surmounted by the rider raker. We ensure that this angle doesn't exceed 75 degrees. Now, in case of tall buildings, we add the rider raker in order to reduce the length of the raker. So, let us say above the top raker, we are adding another raker, and the angle has to be maintained at 75 degrees. So, we want to restrict the length of the raker, which is at the top for a very tall building. That is when the rider raker comes in place. And proper bracing has to be done at regular intervals. So, these are the bracings that are added at an angle to the rakers. They are connecting the wall plate and providing additional support to these rakers at regular intervals. The size of the rakers should be decided considering the anticipated thrust from the wall. That is, how much of bulge has happened, what is the load on this wall, what type of material and self weight of the wall we are dealing with. Based on that, we will determine what is the size of the rakers most suitable for this situation. Now, shoring may be spaced out throughout the building at about 3 to 4.5 meters spacing if longer length of wall needs support. Now, the sole plate should be properly embedded into the ground at a proper inclination. We know that the sole plate cannot be horizontal, it is at an angle. Since wedges are likely to give way under vibrations, they have to be used in the sole plates. We have to ensure that hoop irons, proper cleats, everything holds this in position. The next type of shoring is called flying or horizontal shores. This is used to give horizontal support to the adjacent and parallel walls, which has become unsafe due to removal or collapse of an intermediate building. It is possible that we may have two adjacent walls, and we do not have the possibility of taking support from the ground. Maybe there is lack of space, maybe the portion that needs to be repaired is much higher up from the ground level. There may be several situations in which we will feel that it is better for us to go for a flying or horizontal shore, which is taking help from adjacent walls. So here the type of arrangement is such that we are connecting two adjacent walls or two adjacent buildings without taking help from the ground underneath. Now this allows us to keep the entire lower portion of the building free from any raking shores, any temporary structures. So it is a clear space for one to continue working or doing construction work at the ground level. Now all types of arrangements for supporting the unsafe structure in which the shores do not reach the ground, it will fall under the category of flying or horizontal shores. Now if it is such that the distance between the two walls or two buildings that are holding hands or taking support from each other, if it is less than 9 meters distance, we will go for single flying shore. If the distance is more than 9 meters, we will go for double flying shore. So this is the distance that we are talking about between the two walls. If this is less than 9 meter, we will go for a single flying shore, that is only one member is used. In case if it is more than 9 meters, we will have two horizontal parallel members. So flying shores has various component parts, including wall plates, needles, cleats, struts, horizontal shore, straining pieces and folding wedges. So the straining pieces and the folding wedges actually help us keep the struts and the flying shore in position. So the horizontal member is the flying shore. We are taking some connection between the wall plate and the flying shore with the help of the strut. Now this strut has to be kept in position so that it does not slip along the horizontal shore. That is where we are adding the straining piece and we are holding it in position with the help of folding wedges. Now when the distance between the wall is more a compound is more than 9 meters, we can go for the double flying shore. The advantage is that the building operations at the ground level are not obstructed, so we can continue all construction processes, movement along the ground floor area. So there are certain important considerations we have to make while looking at flying shores. The center lines of flying shore and struts and those of the wall should meet at the floor level of the two buildings. As you can see here, all connections are at the various floor levels. The horizontal shore should be placed either midway between the levels of the two floors of equal strength, or it should be placed at the level of the weaker floor if the floor levels are different. So it is possible that the two adjacent buildings will have the floor levels exactly at the same level, or it may be different. Based on the situation, we will decide what is the position at which we are going to place our flying shores. An inclination of 45 degrees is preferred for the struts. In no case the inclination should exceed 60 degrees. So this is unlike the situation of raking shores where we had the angles ranging between 45 to 75 degrees. In this case, we are going to not exceed 60 degrees. Now single shores should be used only up to 9 meter distance between the walls. We have already discussed this. Now double shores we can provide for greater distance. For double shores, both the horizontal shores should be symmetrically placed. So they are going to be parallel to each other, symmetrically placed. We are also going to use the same arrangement of using struts held in position with the straining piece and the folding wedges. But for additional support between the two flying shores, we are going to have posts and braces. This looks a lot like trusses where we are holding the two pieces together and taking somewhat from the adjoining wall as well. All of this is being held in position with the help of a straining piece and the folding wedges. 3 to 4.5 meter distance should be there between the flying shores. So along the length of the wall, as the building continues, at every 3 to 4.5 meters we have to repeat this arrangement of providing support between the two adjacent buildings. Now adjacent shores should also have braces between them for additional support. As it is difficult to assess the actual load, we are dealing with a structure which is temporary. It's very difficult to assess how much of a consideration has to be made. So it is always better for us to go for a very large factor of safety when we are trying to decide what should be the size of each shore, the section of each shore. So for that, go for something which is a little larger than necessary. That way we have a higher factor of safety. When any old building is being removed, flying shores should be inserted and should be kept in position till the construction of the new unit is completed. So we will allow the building to first be made, to settle, and then we can remove these temporary supporting structures. The next type of shore is called the dead or vertical shores. Now primarily this is used when we are rebuilding the defective lower parts of a wall, or we are rebuilding or deepening the existing foundation, or we are making a large opening in an existing wall at a lower level. So what this shore is doing is it is supporting the portion of the wall above the opening. So if I am providing shoring at this level, I can create an opening in this lower part, and the upper part of the wall will not collapse because the needle from the dead shore is holding it in position and providing it support. Now vertical members that are used in this situation are called dead shores, and they are supporting horizontal members as shown here, and these horizontal members are called needles. Additionally, there are also bracings supporting each of these dead shores and the needles that are passing through the wall at regular intervals. The needles transfer the load of the wall to the dead shores. Holes are made in the wall at suitable height, and needles which are made up of wooden sections are inserted into these holes. Now each needle is supported at its two ends by the vertical posts, which are also called dead shores, and the dead shores are placed away from the wall to avoid disrupting repair work. So we do not want to put the dead shores exactly near the wall. It will be very difficult for us to approach the wall. Say we are trying to create an opening inside the wall at the lower level. I actually have to be able to approach the wall and have enough space for, to do the construction work. So that means keeping the dead shore very close to the wall is also not advisable. So we want to create a situation like a seesaw. So we have a needle, and then at a distance from the wall, which is acting like the fulcrum in between, we can have the vertical members or dead shores. For transferring loads safely, the section of the needle and the dead shores should be adequate. The needles are spaced about 1 to 2 meters. For openings, a minimum of 3 needles should be used. As one can see over here, 3 needles have been used, and that will allow us to create this opening at the lower level, which is shown by the dotted line. The needles should also be properly braced for additional support. That will be taken help from the dead shores also. The length of the outer dead shore will be greater than the inner ones if the opening is made in an external wall. So why this is happening is because we are making adjustment for the plinth level, because we are dealing with not an opening between two rooms, we are dealing with an opening being created in a wall between a room and the outside. So definitely at one side, that is the external side, we need a longer vertical member because we are going to take support from the ground. We are not at the plinth level anymore. Some important considerations that have to be made when dealing with dead shores include that the sole plate support the dead shores and folding wedges are inserted between them. So if you see the figure here, there is a sole plate, which is this member resting on the ground, and the dead shore and the sole plate are connected with the help of the folding wedges. This allows us to secure it into position. Adequate support should be provided to the floors from inside because we are trying to create an opening in an existing wall, And we are taking help from the needle and the dead shore to support that particular wall where the opening is being created. Nonetheless, because we are altering the support that the slab is getting, we want to give additional support to that floor slab as well. So for that, inside the room, we are going to use some amount of a support system using wedges and sole plates, and these members are going to provide additional support to the floor slab above. If we are dealing with a situation where the external walls are weak, we might need to take additional help with the help of raking shores. So what we are going to do is we are going to use dead shores to help us create the opening in the wall, and the rest of the wall will be supported with the help of raking shores, which is the first type of shoring that we had studied. Now, shores should not be immediately removed after the construction has been done. We need to keep it for at least 7 more days. It should be removed only when the new work that we have done has gained sufficient strength and we know that the structure is now stable. Then we can start removing the different pieces supporting the floor slab from inside the room or the opening area or the needles used to create this opening. Now, how do we remove this? We are going to remove the shores at a particular sequence. We first start with the needles. So that will be the first thing that will be removed. This is the needle which was passing through a hole in the wall. Then the strutting has to be removed. Then the floor strutting. This is the floor support system that we had, that will be removed third. And finally, if you have any raking shore which was providing additional support to the external wall from outside, that will be removed last. And minimum 2-day interval should be allowed between each one of these removal operations. So we want to ensure that as we remove the different parts of shoring, the building is stable. So we check whether it is stable over an elongated period of time, then we go for removing the next support. So that is all we had about shoring. So shorings are temporary structures which are used to give support to a temporarily weak wall or a wall which needs some form of opening or alteration to be made. So there were 3 types we studied. We first started with raking shores, followed by flying shores which does not take support from the ground, and the last type was the dead or the vertical shores. Now we will start with scaffolding, which is another type of temporary structure used in construction. So what do we mean by scaffolding? These are temporary structures that are constructed to aid the workers during various stages of construction. They support a platform over which the workers either sit or stand during the construction activities. Now, obviously, when we are dealing with any form of construction activity which is beyond the height at which a human being can reach, we will need some sort of a platform on which we can stand and work. Now, obviously, a ladder will not be useful in every situation because there might be masonry work, painting work, plastering work that one is doing at a greater height. How does one paint the ceiling? It is very difficult to do so while standing on a ladder because we need place to keep all our paints, our brushes, other tools that we need, and have a safe platform on which we can stand and work. That is where scaffolding comes in place. They are usually needed when the height of the wall, column or any other member that we are working on or constructing, it exceeds 1.5 meter in height. Scaffolding can be made up of timber or they can also be made up of steel. Apart from new constructions, scaffolding may also be used if we are doing repair work in old buildings or we are trying to demolish parts of a building. It should be sturdy enough to support the workers and all other necessary tools and materials that one needs to carry on the platform to be able to do the construction work. There are many advantages of scaffolding. First of all, it enables us easy access for construction work. We do not need to strain our hands to try to reach the upper levels, and we do not have to be on an unsafe ladder. So it provides a perfect balance for the workers and provides safety during construction. Most scaffoldings are designed in such a way that not only it provides a working platform for the workers, it also keeps them safe from falling down and also protects other tools and equipment that is used at a higher level from falling down. So there are proper railings which are provided, toe guards which are provided, which prevent these materials from rolling off the platform. So they provide a very safe and balanced platform on which the construction work can be done. Definitely because of this, it boosts construction productivity. Otherwise, it would become very difficult, and it would also make the finishing of all the building parts above 1.5 meter to be good. To ensure that the finishing is good, that we maintain levels and the proper look or aesthetic is maintained, we need to ensure that we provide them a proper working platform. Mostly scaffoldings are very easy to assemble and disassemble. It is not something that requires very complicated or skilled laborers. It is easy to do. Scaffolding also lasts for the significant amount of time that is needed to complete the construction process. Before we start learning about the different types of scaffolding, let's first see what are the component parts that are joined together to create this type of temporary structure. So the first member that we use in scaffolding is called standards. So standards are the vertical members. As one can see, I am highlighting in the figure. These vertical members are called standards, and they are forming the main supporting framework on which everything else will be fixed. So this type of member, this vertical member, can be supported on the ground directly by embedding it into the ground, or we can take help of certain drums to provide some form of a pedestal at the bottom. The second member is called ledgers. These are the horizontal members. So we need horizontal and vertical members together to create a network on which we can place the platforms. Braces, these are diagonal members which are fixed onto the standards. So as you can see in the figure, there are inclined members which are forming a cross. These are holding the adjoining standards together. Put logs are transverse members, and these are placed at 90 degrees to the wall. One end they are supporting the wall, the other end they are connected to the ledgers. So these are the put logs. The horizontal members, as one can see, are connected at one end on the wall and the other end at the ledgers, or the horizontal members which are connected to the standards. Standards were the vertical members. Transomes are those types of put logs whose both ends are supported on ledgers. The previous case, when we were talking about the put logs, they are connected at one end to the wall, the other end to the ledger, but the transomes in both ends, they are supported on the ledgers. Now when will this situation arise? We will see how there are different types of scaffolding. Sometimes we take support from the wall. Other times we create two parallel layers of scaffolding supporting each other, which is called an independent scaffolding because it is not connected to the adjoining wall. We will study that in detail, but in that situation one cannot support the put log in the wall. It has to take support from the adjoining ledgers. So the two parallel layers of scaffolding and the horizontal ledger between them will be supporting the put logs. The burdle is a member which is used to bridge a wall opening, and it supports one end of the put log at the opening. The boarding are horizontal platforms. This is the platform on which the workmen are going to keep their tools and materials and work. This is supported on the put log. So that means the put logs are in turn supported at one end to the wall, the other end on the ledger, which is a horizontal member. The boarding is supported on top of these put logs. So these are the planks or boardings, which I am hatching in the figure right now. The guardrail is a railing which is provided alongside this ledger at the working level. This is to prevent the workmen from tipping over. So this guardrail is going to protect the person standing from tipping over this railing. Now toe boards are also similar to guardrails. They are at a lower level. They are ensuring that the materials that are placed on this board doesn't roll over. So let's say we have certain equipment over here. We don't want it to roll over and fall off. Obviously from a greater height they can cause a lot of damage to people or other things which are kept at the bottom at the ground level. So for safety we have to ensure that we have some amount of guarding to prevent this from rolling over at the toe level. Lashings are ropes or cloths which are used to tie the members. These are the connections. At everywhere we are making two members meet, we need to tie them together with the help of some rope. We can also use cloth. Use of torn reusable cloth is very common nowadays in construction sites if you are dealing with timber scaffolding, that is, and these lashings will help us connect them. Now this is of course applicable to a situation when we are dealing with timber members or bamboo members to make scaffolding. Definitely if you are going for steel scaffolding, we have to use alternative parts. Now let's take a look at what are the various types of scaffolding. Single scaffolding, it is also called brick layering scaffolding. So this is used in brick masonry walls. The second type is double scaffolding or mason scaffolding. It is also commonly used in stone masonry walls because it's difficult to take support from the wall or create holes in the wall to attach our put logs. In that situation, it is better for us to create an independent scaffolding which is a little separated from the wall. There are two parallel layers of standards to support this entire temporary structure. Cantilever or needle scaffolding. There's another type called suspended scaffolding, trestle scaffolding, steel scaffolding which instead of using timber uses steel parts, and also patented scaffolding which has certain patented specific parts. We will now take a look at each of these types of scaffolding one at a time in detail. So let's first start with single scaffolding. This is also known as the brick layer scaffolding, as already mentioned, because it is commonly used for brick layering. So if we are dealing with a masonry wall where we are building above 1.5 meter, we are going to need some scaffolding to do the same. These are constructed, this type of scaffolding is constructed parallel to the wall at a distance of about 1.2 meters. They comprise of a single framework of standard, ledgers, braces, putlogs, etc. So it's the wall, and in front of the wall there is only one layer of standard, and that is connected to this wall. So that means we will have only one standards layer, one layer of ledgers or horizontal members, and we will have putlogs which are connected at one end to the wall here, and the other end it is resting on the ledger. Above this we are going to place the planks or the boarding. We are going to provide the guardrail, we are going to provide the toe boards and keep it in position with the help of lashings. Standards in this case are placed about 2 to 2.5 meters interval. So that means if I go along the wall, this distance will be 2 meters to 2.5 meters. The standards can be embedded directly into the ground, or we can use some drums to support them. So if one sees the elevation, we see the usage of drums, whereas here in the section we can see how standards can also be embedded directly into the ground. The ledgers which are used in single scaffolding are connecting the standards. They should be kept at a vertical interval of 1.2 to 1.5 meter. So like between the standards we had 2 to 2.5 meters distance, here vertically between the ledgers, that is this distance, this will be limited to 1.2 to 1.5 meters. The guards, boarding and other members should also be placed accordingly. The next type of scaffolding is called the double scaffolding or the mason scaffolding. Because this is not connected to the wall, as one can see here, there is a significant distance between the first layer of standards and the wall alongside which it is being created. Because this gap is there, this scaffolding is actually standing on its own. That is why it is also known as the independent scaffolding. Stone masonry makes it very challenging for us to support the putlogs by creating holes inside the stone wall, because otherwise this would have been called a putlog, it would have to be inserted into the wall. It would be difficult to do in case of a stone masonry wall. So we have to go for the usage of transomes where the putlog is not connected to the wall but it is supported on both edges with the help of ledgers. 2 rows of scaffolding are being used in this case. So definitely it will be a stronger version of scaffolding as compared to the previous single scaffolding. and each row in this case, that is row number 1 and row number 2, these will have separate vertical framework. Now sometimes to ensure that while we are working on this platform that it doesn't tilt over in this direction, we might take the help of rakers. With the help of a sole plate, we can hold the raker in position and ensure that it supports this double scaffolding or independent scaffolding. Individually, each layer of standard is secured onto the ground, but still to ensure that due to weight it doesn't fall over, we can go for the usage of raking shows. So the first row, that is this row, this is the first row of standard, is kept at 20 to 30 centimeter away from the wall. The second row is placed at 1 meter distance from the first one. So this distance we can keep at about 1 meter. That means we will have at least 1 meter gap to place our working platform. So it is a pretty wide, comfortable platform on which we can work as well as keep our equipments and other materials. The put logs are placed on this such that it is taking help from the two adjoining supports. To increase the scaffolding's strength and stability, raking and cross braces can be provided at regular intervals. So though in this figure we can see the rakers along the length of the wall, we can also provide additional bracing. The next type of scaffolding is called cantilever or needle scaffolding. They may be single type, that is a put log scaffolding, that is one end is connected to the wall, the other end is connected to the ledger here in this example. Or it can also be the double type or the independent scaffolding, where we have two layers of standards 1 and 2, and it is placed at a slight distance from the wall, and the independent cantilever needle scaffolding has been created in this situation. Now in independent type, the needles or the projecting beams are strutted inside the floor through the openings. So as one can see, there is an opening in the wall here. This is the needle, this is the strut that is passing through the opening into the floor, and it is being held in position inside the floor with the help of a wedge. Now this is a situation of double cantilever scaffolding. If we have a single layer, in that case the put log is embedded on the wall, at one end it is embedded on the ledger on the other end, and this is being supported with the help of a strut taking help from the chhajja or other crevices or corners on the wall. If you are dealing with double scaffolding, we actually have to enter into the room and take support from the floor inside. Suspended scaffolding is another typology. Now though independent scaffolding, which we just took a look at, cantilever or needle scaffolding also is not taking support from the ground. This type of scaffolding is actually being placed at a level higher up. We are taking support from openings or from inside the room. It is not taking support from the ground like the single and double scaffolding that we had taken a look at previously, where the standards are being supported on the ground. In this case also it is taking support from inside the room at a higher level, but still we should not confuse this with the next type, which is the suspended scaffolding. Here we are actually suspending or making the member or working platform float above the ground. We are taking support from the roof or the top of the structure, and this scaffolding actually remains suspended mid-air. So these are very lightweight scaffolding because you are suspending it from roof level. Normally they are used for painting, pointing, repair work. Even in case of very tall buildings, if we need to clean the outside surface, I am sure all of us have seen very tall buildings with glass generously used in its facade that has to be regularly cleaned. So for that also we can use this type of a suspended scaffolding framework, where the workmen can alter the height of the scaffolding based on which position they want to clean or which floor they have to paint or do plastering on. Now the working platform is suspended from the roof by means of wire rope or chains. So it's a very similar situation to pulleys. We have a pulley that is helping us suspend this With this pulley, we can also change the height of the scaffolding. The suspended scaffolding can be moved along the height of the building, and accordingly we can do the work at different levels. Now this platform can be raised or lowered with the help of this arrangement, as one can see here, and the suspended platform can be moved with the help of power controlled devices, or it can also be manual. So if we are dealing with a traditional form of suspended scaffolding, we can simply use pulleys and manually shift the position, or we can also go for a mechanized format in which with the help of a motor we are controlling the height. The next type of scaffolding is called trestle scaffolding. This type of scaffolding is very useful if we are doing repair or painting work inside the building. This is kind of like having a platform on wheels. So normally trestle scaffolding's position can be changed within the room based on which part of the room we are working on. Trestle scaffolding can be made up of timber or even metal steel members. We can have them with the help of tripods or stands as depicted here, or we can also use wheels which can be locked in position. So caster wheel trestle scaffolding can also be done. Normally they are used with steel trestle scaffolding. In case of timber option, it is like creating different stands which will help us secure it in position throughout the room. So normally when we do plaster work of the ceiling or painting of the ceiling, or any repair work has to be done because of damping or other such construction problems, that time trestle scaffolding is very useful to go about moving throughout the house, creating construction works in different places. Now this is not definitely used for external applications. So if you want to do some repair work or painting or plastering outside or on an external surface, on the external wall of the building, definitely single or double scaffolding or cantilever scaffolding, even suspended scaffolding would be useful in that situation. So trestle scaffolding is more of an internal within the house usage, whereas suspended scaffolding, for example, which we just learned, is more of an external suspended work. So definitely we will not see a suspended scaffolding inside the house. Now the working platform is supported on the top of movable contrivances. They can be tripods, ladders, etc., and the entire scaffolding can also be mounted on wheels. Now then comes the steel scaffolding. The previous types that we were studying, we were paying greater attention to timber type of scaffolding. So similar to timber scaffoldings, we can also replace these wooden members. Concept remains very similar, but we replace the wooden members with the help of steel tubes and steel couplets or fittings, and instead of rope lashings or cloth lashings, we are using steel couplings and fittings to hold the different members in position. Now the advantage of steel scaffolding is that they can be erected and dismantled very rapidly. We do not need to be very slow and careful with constructing this type of scaffolding, because the members or the component parts are very strong and durable. So definitely this type of scaffolding will have greater strength, greater durability, and also fire resistance, because timber members, you can fairly understand, is highly inflammable. On a situation that it catches fire, it will definitely be a big hazard in the construction site. But the steel scaffolding protects us in that respect. It will not be damaged very easily, and also it provides a lot of support for heavy materials to be carried on the platform. A lot of people, more number of masons or laborers can work on these platforms together at the same time. And because steel scaffolding component parts can last for a very long time, they can be used and reused multiple times in different construction sites as well. Oftentimes when we use timber scaffolding, if they are removed again and again, the component parts undergo damage and they might lose their longevity over a period of time. We will not be able to use it on a very large number of construction sites again and again. But steel scaffolding, though the initial cost or capital investment is going to be higher, because the first time when we buy this, the parts will definitely cost more, but because they can be used and reused due to their durability, in a long period of time it becomes advantageous to us. So it looks very similar in arrangement to the timber situation, but here we are using steel tubes for the standards and the ledgers. We are connecting each of the parts with the help of metal pieces or couplets instead of tying it with ropes. On top of the steel scaffolding, we may choose to have metal sheets as the planks or as the platform on which the workmen will work, but we can also go for wooden planks supported on this steel framework. Both are used. So definitely we have some main cross pipes which are connected. This is a situation where a transom, you can see, is placed at an angle 90 degrees to the ledgers, and on top of that we provide the working platform and we have the toe guard placed. So as you can see, it's very similar to what we were doing in the timber situation, just the material is different. The arrangement is very same. Now patented scaffolding are a type of metal scaffolding in which special couplings and frames are used. So here what we do is we are connecting the standards and the transoms with the help of special type of metal members which have been patented. Now the height of the working platform in this case can be adjusted as desired because they are supported on brackets. So at whichever level we are currently working, we can change the position of the transoms and we can accordingly change the position of the working platform throughout the scaffolding. So this is the speciality of the patented scaffolding. We can alter the height of the working platform based on our context and usage. Now this is a very independent scaffolding format, so this will not take support from the adjoining wall, but it will be 2 layers of vertical standards which are independently standing on the ground and supporting this working platform. Now the members are connected together using an integral locking device. So instead of using the very conventional clips and couplers that we were seeing in the steel scaffolding, definitely no lashing will be used also in this case like the timber scaffolding. Here we are using integral locking devices at regular intervals to secure the position of these members. Now patented scaffolding are very easy to assemble and they are also easy to take down after the construction work is done. We can use even semi-skilled laborers, so it's not that because it's patented scaffolding we will require very specialized workmen to set this up or dismantle it on site. Cross bracing is not required, but facade bracing may be fitted if it is necessary. Now because this type of scaffolding is very strong, we do not need to incorporate cross bracing for additional support. We may provide some form of facade bracing to necessarily keep these standards in position. They lack the flexibility, however, of the traditional tubular scaffolds, that is the steel scaffolding we were talking about. Some amount of flexibility will be compromised. So that was all the type of scaffoldings we have taken a look at. So in this particular lecture, what we have done is we have started learning about the temporary structures which are used in construction, and we have first learned about shoring and second we have learned about scaffolding. Now what was shoring? Shoring is when a temporary structure has to be erected to give support to a wall. So either the wall is bulging out or some repair work has to be done or a new opening has to be created and I need to provide additional support to this wall to prevent it from collapsing. Then I will go for shoring. Now shoring, as we have learned, is of 3 types. Raking shores are inclined members which is taking support from the ground and supporting the wall. The flying or horizontal shore is taking support from 2 adjoining walls. If this distance is less than 9 meters, we will use only 1 single flying shore, but if it is more than 9 meters, we will have 2 flying shores to ensure greater stability. The third type of shoring is dead or vertical shore. Here what it is doing is, if we are trying to create an opening in a wall, the needle which is passing through the wall is supported at both ends with vertical shores or dead shores. This is mostly useful if you are trying to create an opening inside the lower part of the wall or doing some repair work in the lower part of the wall. Then we went ahead and started studying about scaffolding. Now scaffolding is different from shoring. How? Shoring is supporting a wall temporarily. Scaffolding is creating a working platform Temporarily, we are creating a working platform so that all construction work which is above the height of 1.5 meter, where the workman's hand cannot reach, we need to provide them with a feasible working platform on which they can stand, keep their materials and tools and work in that part of the upper part of the building. So, scaffolding has many types. The first one was single scaffolding, which is also called the bricklayer scaffolding. In this case, we are taking support from the wall, we are adding the members in front of this wall. But in double scaffolding, which is also called the mason scaffolding, we have two parallel layers of standards or vertical members. This is not taking any support from the adjoining wall. That is why it is also called an independent scaffolding. This is very useful in situations where we are dealing with stone masonry walls, where we cannot create a hole in the wall to connect our put logs. Cantilever or needle scaffolding is at a higher level from the ground, and it is taking help of needles and struts and connecting it to the nearby floor, internal space of the house with the help of openings. So, through the opening, the member goes into the room and supports this cantilever or needle scaffolding. Suspended scaffoldings are suspended from the roof with the help of pulleys and other members which help us alter the height of the suspended scaffolding platform depending upon which level we have to work on. The next type was trestle scaffolding. So, this is a working platform which is resting on tripods or on wheels, and the position can be changed throughout the room as and when we are doing the construction work, generally used inside for internal works. Steel scaffolding, very similar to the previous examples of single and double scaffolding. In this case, we are not going for timber members, but we are using steel members, steel tubes or steel couplets to actually connect the various parts. Initial investment is more in this case, but definitely they can be reused many number of times. The last was the patented scaffolding, which is another type of steel scaffolding, but we are having very specific parts, devices which are used to connect these components rather than the typical examples of couplets used in the previous example. So, this was all we learned for the shoring and the scaffolding. These are some of the books you can refer to study further in detail. Now, we will gradually move towards the other form of temporary constructions in the next lecture. So, thank you for joining in. Today, we learnt about shoring and scaffolding, and let's meet next time to learn about the rest of the types of temporary structures. Thank you.